Okay guys, let's begin the discussion over the questions. First one says that R is less than S is less than equal to N. NPR is NPS, then what is the value of R plus S? Now it's pretty easy. If NPR is equal to NPS, that means N factorial upon N minus R factorial equals N factorial upon N minus S factorial. Direct implication of the formula. This eventually means that N minus R factorial equals N minus S factorial. Now once you've got this, what is the next step? See, R is less than S. R is a quantity which is less than S. So when from N you are going to remove R, and when from N you are going to remove S. R is less than S, so N minus R will be greater than N minus S. If N minus R is greater than N minus S for sure, and their factorials are same, what is the only possibility for N minus R and N minus S to obtain values for? There is only one case. We know that 1 factorial is 0 factorial when 1 is greater than 0. There is no other scenario in which one number is greater than the other number but their factorials are same. If one number is greater than the other number and their factorials are same, this just implies that N minus R is 1 and N minus S is 0. So N minus R is 1 means R is N minus 1 and S is N. I have to find R plus S. So R will be what? It is N minus 1 plus S is N. So you get 2N minus 1 as your answer. Your answer is option number B. Fine, pretty logical. Let's move on to the next question. We have E is given to us and that is equal to 8 to the power x. Then the value of x is what you need to determine. Now see, if you carefully observe the numerator 1, 2, 3, 4 up till 31, obviously E is nothing but 31 factorial whole upon. Now you are going to take out 2 common from each term in the denominator. This can be written as 2 into 2, 2 into 3, 2 into 4, 2 into 5 and so on. Eventually 2 to the power 31 is going to come out. Why? 31 times is going to come out. Inside you will be left with 2 into 3 into 4 into 5 and so on into 32. Right? You will be left with 2 into 3 into 4 up till into 32. Which means E is 31 factorial upon 2 to the power 31 into 32 factorial. Which is 31 factorial upon 2 to the power 31 into 32 into 31 factorial. 32 can be written as 2 to the power 5. So 2 to the power 31 into 2 to the power 5 is 2 to the power 31 plus 5, which is 36. The moment it is 2 to the power 36, what is the next step? 2 to the power 36, or I can write it as 2 to the power minus 36 in the numerator, which is 2 to the power 3 into minus 12. Why I am wanting 2 to the power 3? Because this is equal to 8 to the power x and I know that 2 cube is 8. I am getting this equals 8 to the power x. But actually it is coming out to be equal to 8 to the power minus 12. So you are getting x equals minus 12. X is coming out to be minus 12. Moving to the next question, what is it that we have? Let's see. What is the exponent of 7 in 100 C50? Now for this, 2 things we need to know. One is, what is the exponent of 7 in 100 factorial? What is the exponent of 7 in 50 factorial? So exponent of 7 in 50 factorial is what? 50 by 7 greatest integer function plus 50 by 7 square greatest integer function, after which it is going to be 0. So we stop over here. This becomes 7 plus 1, which is 8. And then you need to know next exponent of 7 in 100 factorial, which is 100 upon 7 plus 100 upon 7 square. This eventually gives you 14 plus 2, which is 16. When you connect both of them, you basically get the exponent of 7 in 100C50. What is that? It is 16 minus twice of 8, which is 0. 16 minus twice of 8, which is 16 minus 16, which is 0. Clear? Moving on to the next one, we have, let Tn denote the number of triangles which can be formed by using the vertices of a regular polygon of n sides. Now for a triangle, we need 3 sides. We are available with n sides, so we can make how many triangles? NC3 is the total number of triangles which can be formed by using 3 vertices out of the n vertices of a regular polygon. And that is equal to Tn given in the question. I am given that Tn plus 1 minus Tn is 21. If NC3 is Tn and Tn plus 1 will be n plus 1 C3 minus NC3 equals 21. You should know that n plus 1 CR equals NCR minus 1 plus NCR. So n plus 1 CR is NCR minus 1, that means 3 minus 1, which is 2, plus NCR, and here minus NC3. This gets cancelled out. You are left with n factorial upon 2 factorial into n minus 2 factorial. This is 21, which eventually gives you n into n minus 1 into n minus 2 factorial upon n minus 2 factorial, that cancels out, upon 2 is 21. You resolve this, you get n equals minus 6 and 7. So n actually comes out to be minus 6 and 7, out of which the options is supporting just 7. Moving to the next question, we have, if n plus 2 C8 is to n minus 2 P4 is 57 is to 16, then n minus 12 is what? Okay, so n plus 2 C8, that means n plus 2 factorial upon 8 factorial into n plus 2 minus 8, which is n minus 6 factorial, whole upon n minus 2 P4, which is n minus 2 factorial, upon n minus 2 minus 4, which is n minus 6 factorial. Right? This is equal to 57 by 16. Very clearly this has got cancelled, not a problem. From here you get n plus 2 into n plus 1 into n minus 1 into n minus 2 factorial. I can write it like this, whole upon n minus 2 factorial. Here you get 57 into 8 factorial upon 16. This gets cancelled. You are just left with this expression. Very easily you can evaluate that n comes out to be 19 and minus 20. But n is not negative, therefore n is going to be 19. The moment n is 19, 19 minus 12 gives you the integer 7 as the answer. Okay? Let's look at the next question. We have m and n are two positive integers such that m is greater than or equal to n. Okay. Then, what are the number of ways of distributing m distinct books among n children? Now see, if there are n children, okay, this is A1, this is A2, this is A3, n children. And there are m books. First book can be distributed in n ways. Second book can be distributed in n ways. It can be given to either this or this or this or this or this. Third book again can be distributed in n ways. Fourth book again can be distributed in n ways, and so on. Mth book again can be distributed in n ways. So in how many ways can all the m books be distributed? N into n into n into n, m times, which is n to the power m. So A gets matched to R. Next is arranging n distinct books at m places. Now you know that m is greater than or equal to n. If I have n books with me and m places are there, first of all I am going to choose n places from the available m places that I can do in mcn ways. Right? I want to arrange n books in m places, so from m places I will first choose n places where I want to arrange the books. And now in those n places I can arrange n books in n factorial ways. So mcn into n factorial, which is s. Selecting m persons out of n persons so that two particular persons are not selected. So it is basically saying that there are two particular persons which are not supposed to be selected. So if overall there are m persons, and out of, okay, so overall there are n persons and you want to select m persons. So overall there are n persons. Out of these n persons, there are particular two persons which are not supposed to be selected. So now your choice is among the available n minus 2 persons. There are n people in total, out of which two particular persons are devoid of being selected. So now you're left with n minus 2 persons. From these n minus 2 persons, you want to select m persons. Now, you have n minus 2 persons, you want to select m persons. First of all, does that even make sense? Let's understand. It is given to us that m is greater than or equal to n is obviously greater than n minus 2. M is coming out to be strictly greater than n minus 2. If m is strictly greater than n minus 2, how can I choose m persons from available n minus 2 when n minus 2 is so small than m? That means this is not at all possible. There are 0 ways to do so, and therefore P gets selected against C. Then you have number of functions from 1, 2, 3 up till n to 1, 2, 3 up till m. Now this is very nice because m is greater than n, so the codomain has more members than the domain. Domain has n members, codomain has m members. The first, that is 1, can be mapped in m ways, 2 can be mapped in m ways, 3 can be mapped in m ways, and so on, n can be mapped in m ways. So basically m into m into m n times, that is m to the power n, so Q gets matched against D. Clear? Moving to the next question, let's see what we have. Consider all possible permutations of the letters of this particular word. Match the entries in column 1 with entries in column 2. Number of words containing the word ACHIT. Okay, so ACHIT, this is one word. I have collected all these 5 letters and considering them as one single letter because wherever they're going to go together. Apart from this, what are the available letters? So ACHIT I have removed. I'm left with R, 2 R's I'm left with. IHCA. So basically there are 7 letters which I need to permute. 1, 2, 3, 4, 5, 6, 7. Ways are 7 factorial upon, because of these repetition, 2 factorial. There is no repetition over here, so this is the only way. So here I am getting 7 factorial upon 2 factorial because here I want ACHIT to be the arrangement. I don't want them to be permuted among themselves. So here is where I stop and this answer comes out to be 2520. A gets matched to S. Okay, this comes out to be 2520. Then you have number of words beginning with RA and ending with AR. If it is fixed that they are beginning with RA and it is fixed that they are ending with AR, now what am I left with? Let's see. So A and R are blocked, R and A are blocked. CHITIHC. So 2 C's I am left with. Then 2 H's I am left with. Then 2 I's I am left with and 1 T I am left with. Right? 2 C's, 2 I's, 2 H's and 1 T. So this is fixed. How many ways can I permute these now? 1, 2, 3, 4, 5, 6, 7. 7 factorial upon 2 factorial into 2 factorial into 2 factorial because there are 2 C's, 2 H's and 2 I's. And this number comes out to be 630. Q gets matched. Next I have number of words in which vowels occur together or vowels occur at the odd places. That's what it is saying. So vowels wish to occur at odd places. Now in here if you try to carefully see what are the odd places. 1, 3, 5, 7, 9, 11. How many odd places are there? 6 odd places. And how many vowels are there? A, I, and A. 4 vowels are there and 6 odd places are there. First of all, 4 places out of 6 places can be selected in 4 ways. In those 4 selected places, 4 vowels can be arranged in 4 factorial upon 2 factorial into 2 factorial ways. Why? Because they are not 4 distinct vowels. It is actually A and I only. I is repeated twice, A is repeated twice. So this is the number of ways in which 4 vowels, that means 2 of the same kind and 2 of the other same kind, can be arranged in 4 available places out of 6 available places. But this is only the arrangement of vowels in odd places. Now I am left with what all words? I am left with R, C, H, T, H, A. So I am left with what? R, C, H, T, H. No, I am not left with A. I am just left with what? So this I have used, this I have used, this I have used, and this I have used. I am left with R, C, H, T, H, R. Right? Now that I am left with this is what? 1, 2, 3, 4, 5, 6. If vowels can be arranged in odd places in these many ways, remaining letters are these which can be arranged in the remaining places in how many ways? 6 factorial upon, so there are 2 R's and there are 2 H's. So this is 2 factorial into 2 factorial. Fine. This is your number of letters now. So it is R, C, H, T, H, R. And that is what it is, C. Okay, so R we have covered, C, H, T, H, C, R. So there is one more C. So actually this has to be 7 factorial and one more 2 factorial. Okay, so there are 7 letters, 2 C's, 2 R, 2 H's and 1 T. So this is the total number of ways of arranging the 4 vowels, out of which 2 are of one kind and 2 are of the other kind, in 4 odd places out of the 6 odd places, and in the rest of the ways, in the rest of the places you are arranging the available non-vowel letters or consonants. And that number comes out to be 56,700, so P gets matched against this. Then it is saying the number of words in which the word IIT appears. Okay. Now when I am talking about IIT, if I want this to occur, I am going to just consider this as one single letter. Now that I have considered IIT as one single letter, I gone, and T gone. I am now left with 1, 2, 3, 4, 5, 6, 7, 8. 8 letters, out of which now there are, this is R, A, C. Let me write R, 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 A. Then I have C, C, and then I have H, H. So there are just 9 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9. I can arrange them in 9 factorial upon 2 factorial, 2 factorial, 2 factorial, 2 factorial ways. I am not allowed to permute I, and T because I want this word to be like this wherever it is going. It cannot be ITI or TII, right? Now therefore, that number comes out to be 45360. So R gets shaded against it. Let's move on to the next question. We have the paragraph question which is talking about a specific function. Let's try to study the function. What is it saying? It's saying that phi is a function from the collection of all natural numbers to the collection of non-natural numbers such that phi is sending 1 to 1 and phi of any prime number to power n is equal to that prime number to the power n minus 1 into 1 less than that prime number. And this is very important for only p prime. Also one more feature is that phi of m into n is phi of m into phi of n provided HCF of m into n is 1. So they have to be co-prime numbers. In that case phi of m into n will be phi of m into phi of n. Question is, what is phi of 4n plus 2? Phi of 4n plus 2. Now I can write this as twice of 2n plus 1. I know that HCF of 2 and 2n plus 1 is 1. Because HCF of 2 and 2n plus 1 is 1, phi of 2 into 2n plus 1 is phi of 2 into phi of 2n plus 1. It's given in the question. What is phi of 2? 2 is a prime, the power is 1. So phi of 2 to the power 1 is 2 to the power 1 minus 1 into 2 minus 1 into phi of 2n plus 1. This is 1 into 1, 1, so you are just getting phi of 2n plus 1 because phi of 2 has come out to be equal to 1, so you are getting C as your correct answer. Let's talk about the next one. We have, if phi of 5 to the power n is 100, then value of n is what? Now see, this is pretty simple. 5 is again a prime number. So phi of p to the power n is p to the power n minus 1 into p minus 1. This is given to be 100. So 5 to the power n minus 1 into 4 is 100. So 5 to the power n minus 1 is 100 upon 4, which is 25, which is 5 square. So n minus 1 is 2 or n is 3. So n eventually comes out to be 3. And next we have, if p is prime and n is a natural number, s is given to be this expression, then it is equal to what? Okay, let's expand s. Phi of 1 in the question is given to be 1. Phi of p to the power 1 is p to the power 1 minus 1 into p to the p minus 1. P to the power 1 minus 1 is p to the power 0, which is 1, into p minus 1. So this is just p minus 1. Phi of p square, again p is prime. This is p to the power 2 minus 1 into p minus 1. And so on, p to the power n minus 1 into p minus 1. I've just used the definition which is given in the question. Let 1 be as it is. Here if you see, this is nothing but a GP with first term p minus 1 and common ratio p. This is your first term and this is your common ratio. So your sum becomes a r to the power n minus 1 upon r minus 1. Because r is p and a is p minus 1. This gets cancelled. You have 1 plus p to the power n minus 1, and your answer is just p to the power n. So based upon the very basic definition which is given to us, that phi of 1 is 1 and phi of p to the power n is p to the power n minus 1 into p minus 1, I have basically resolved all the available questions after this in this paragraph. So go through them very nicely, practice them nicely. That's it from my side. Thank you.